Good morning, children. I hope this new method you are finding better and that you are following what we are teaching. And we all have regularly been organizing the doubt solving sessions. So, if you have any doubt related to this lesson, you must note down as I'm teaching. And when we have the one-to-one interaction, you can always get them solved. So let's resume back with our chapter, chemical reactions and equations. So in the up till last class, we have done various types of reactions, and we have learned how we can make molecular formulas by crossing valencies, and how to balance a chemical equation, that also we have studied, and how we can make the reaction more informative, that also we have studied. What are reactants, what are products, that also we have done. And in the last whatever I had given you, material that I had given you for study, I had shared an iron table in the PDF format. So that iron table is very essential. You have to learn that table. Only when you learn that table you will be able to make the molecular formulas, because that is going to give you the valencies of various radicals. uh, we have compound radicals and positive, negative, cations, anions. Radicals are given there, and the valencies are given, and using them you will be able to make the molecular formula. So that is why that iron table is given. Towards the end, I have given some common molecular formulas that you must remember, like sodium hydroxide, hydrochloric acid, sulfuric acid, nitric acid. So these are very common, and for that you need not make use of the crossing and all, because now that you have to learn them. So you try to make more such molecular formulas. Try to make more molecular formulas, and then you can make a list of all these formulas. Okay, so let's get going with the lesson ahead. And here in this slide, we have just got the salient features of the chemical reaction. What are the salient features? This is what we have already done. Like, first point is, a chemical reaction is a process in which some substances undergo bond breaking and are transformed into new substances by formation of new bonds. So which substances are undergoing bond breaking? So they are the reactants. So the reactants undergo bond breaking, because unless the bonds between the reactants break, they will not form new substances. So bond breaking takes place, and there is rearrangement of atoms and ions, and that results in the formation of new substances. So these new substances are called as products. So a chemical reaction is a process in which some substances undergo bond breaking, that is reactants, and they are transformed into new substances, that is products, by formation of new bonds. So the bonds that will be formed now in the products will be new bonds. So that is one important feature. The substances taking part in the chemical reaction are called as reactants, which are written on the left hand side. Substances formed as a result of chemical reaction by formation of new bonds are called as products. So these are written on the right hand side. The reactants are separated from the products by an arrow, and we write down the physical states to make the reaction more informative by making use of S for solid, L for liquid, G for gas, AQ for aqueous, upward arrow for gas, downward arrow for a precipitate. So this is how we can make it more informative. We can even write down conditions like temperature, pressure, and catalyst on the arrow of the equation. So these are some of the important features of the chemical equation. I hope you are writing down each and every equation in your notebooks. Write down these points also. And now let us go to the next slide. Here we are seeing the types of chemical reactions. Now in this lesson we have to study many types of chemical reactions, but chiefly there are four types of chemical reactions. So these four types of chemical reactions are in accordance with the nature and the number of reactants and products. So how have we classified the various types of reactions? They are classified on the basis of the nature of the reactant. How does it react? How does it behave? And secondly, the number of reactants, whether we have one reactant, two reactants, more than two reactants, what are the products that are formed, whether it's a single product or more than one, and so on. So depending upon the nature and the number of the reactants and products, we are going to classify the equations. So what are the four types of chemical equations that we are going to study in this lesson? These are the combination reaction. The very first is combination reaction. So as the name literally tells us, combination, two or three things are going to combine with one another, and that is combination. We'll see how many reactants are there, how many products are formed, what are common examples of combination reaction that we observe in our everyday life. So all that we are going to study. Second one is decomposition reaction. So decomposition means to break down. We hear about decomposition taking place of organic matter in our surroundings, how complex material breaks down into simple form. So that is decomposition. And third one is displacement. The best example is a football game. If you are seeing, you find that if somebody is injured or somebody needs to be replaced, somebody is asked to come out and someone else takes the place of that player. So it's just displacement. That is a displacement reaction and double displacement reaction. So these are the four types of chemical reactions that we are going to study. So in the next slide, we will be starting with the first type of reaction, that is combination reaction. Okay, let us start with the very first type of reaction, that is combination reaction. To give you just an example of combination reaction from everyday life, we have an experiment of a prism. This prism experiment was first done by Sir Isaac Newton, where he tried to split the white light into 7 colors. So he used a prism for this, and when he made white light or a ray of light pass through the prism, he found that it came out in the form of 7 colors. Then he placed another prism in such a way that the adjacent sides of the prism were parallel to each other. Or he had placed the second prism inverted with respect to the first. So what happened was, white light passed through the first prism, came out in the form of 7 colors. This 7 colored light then was made to pass through the second prism, and it came out in the form of white light. So through this he concluded that white light is a combination of 7 colors. So this is an example of combination. So we see this practical example in whenever there is sunshine immediately after rainfall, and how the small water droplets remain suspended in the air and they act as small prisms. So when white light is going to pass through it, it comes out in the form of 7 colors, which we see it as the rainbow. So this is one example. Let us take the examples that are given here and that we have to study. So the first one is ammonia reacts with hydrochloric acid to form ammonium chloride. So you have the reactants, ammonia, that is NH3, and hydrochloric acid, that is HCl. Both these are actually liquids, liquid ammonia and liquid HCl. But here we have written gaseous states. So why have we written gas? Because you have to take a glass rod, dip it in ammonia solution, and when you take it out, you find the ammonia is in gaseous state. You can see the vapors of ammonia. Similarly, HCl, which is liquid, you have to take it in a hard glass tube and you have to heat it. When you heat it, you get the vapors of HCl. So both the vapors of HCl and ammonia combine with one another and you are getting the product ammonium chloride, that is NH4Cl. This is initially in the form of dense white fumes. So when you bring the glass rod dipped in ammonia, and you bring it near the mouth of the test tube which is containing HCl. So they both combine and they give rise to ammonium chloride, which is in the form of dense white fumes. But these fumes eventually condense, and hence we have written it as a solid. So this is what is the first combination reaction. If you see here, all the atoms have just added up. All the atoms of reactants have just added and they have given you one single product. So this is one nitrogen, here also one nitrogen, 3 plus 1, 4 hydrogen, here also 4 hydrogen, and 1 chlorine atom. So this reaction is a balanced reaction where two reactants have given rise to a single product. Another one is magnesium ribbon is ignited, that is, it is burnt. So when magnesium ribbon is burnt, what happens? We use magnesium ribbons in Diwali as a cracker, and we find that it burns very brightly. So what is the reaction taking place? So we have written magnesium ribbon is ignited, that whenever it is burnt, it is going to combine with oxygen. So you have two reactants here. One is magnesium, metal, that is solid, and oxygen, that is gas. When you are heating, therefore we have shown a triangle here, and they both combine and they give rise to magnesium oxide. The oxide of magnesium is formed, it is ash, and it is solid in state. So this is another two reactants combining to give you a single product. So this is called as a combination reaction. Here we have two reactants in both the reactions, but there can be more than two also. So when two or more reactants combine and they give rise to a single product, it is called as a combination reaction. We will balance the second equation in the next slide and see more examples and definition in the next slide.